Kubernetes review from zero to next level. Hello everyone, welcome back to another awesome tutorial about Kubernetes. My name is Utbek, Associate Cloud Engineer and officially Google Cloud Certified. And in this video, I'm going to explain the basic components of Kubernetes, but we are not going to deep dive into these components or elements of Kubernetes. So without wasting time, let's go to an overview of part 1. I'm going to talk about what is Kubernetes, what are the features of Kubernetes, what is node, pod, service, ingress, ConfigMaps, secrets, and volumes. So first and foremost, what is Kubernetes? Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. It is a portable, extensible platform for managing containerized workloads and services. It's designed by Google and now maintained by the Cloud Native Computing Foundation. Several cloud services offer a Kubernetes-based platform such as AWS, Azure, and Google Cloud Platform. You might ask, what problems does Kubernetes solve, right? So some of the features of this Kubernetes which solves some problems are service discovery and load balancing, horizontal scaling and self-healing, automated rollouts and rollbacks, and secret configuration management, as well as storage orchestration. So let's talk about some of the important elements of Kubernetes, which is node and pod. Let's start with node. A node is a worker machine in Kubernetes and may be either a virtual or a physical machine, depending on the cluster. Each node is managed by the control plane. A node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the pods across the nodes in the cluster. What is pod then? Pod is a basic building block of Kubernetes, the smallest deployable unit in the K8s, which is Kubernetes that can be created and managed. Pod is a group of one or more containers, such as Docker containers with shared storage and network. Pod also represents a single instance of an application in Kubernetes. Let's see the one image which represents about a node and pod. You can clearly imagine in this video about the pod and node. You can see the cluster, and we have a node, and inside the node we have a pod, and inside the pod, as I told, there are one or more containers. So let's talk about the Kubernetes service. A service, an abstract way to expose an application running on a set of pods as a network service. The set of pods targeted by a service is usually determined by a selector. Service can be created with 3 different types by specifying a type in the service spec. For example, the cluster IP, node port, load balancer, which we are going to talk about these 3 types in the next page. And also 2 ways of creating a service would be, the one is kubectl expose and another is YAML JSON files. Now let's talk about the service types. The first service type is cluster IP, which exposes the service on a cluster internal IP, which you have to remember and differentiate. It's a cluster internal IP. Choosing this value makes the service only reachable from within the cluster. This is a default that is used if you do not explicitly specify a type for a service. Another one is node port, which exposes the service on each node's IP at a static port, the node port. To make the node port available, Kubernetes sets up a cluster IP address, the same as if you had requested a service of a type cluster IP. The last type of the service is the load balancer, which exposes the service externally using a cloud provider's load balancer. Let's talk about a Kubernetes Ingress. Ingress is Kubernetes has a built-in configuration object for HTTP load balancing called Ingress. It defines rules for external connectivity to the pods represented by one or more Kubernetes services. The traffic routing is controlled by rules defined on the Ingress resource. There is also Ingress controllers, In order for the Ingress resources to work, the cluster must have an Ingress controller running. And unlike the other types of controllers which run as a part of the kube controller manager binary, Ingress controllers are not started automatically with a cluster. Here is an example where Ingress sends all the traffic to one service. You can see the client, Ingress managed load balancer, Ingress routing rule, service, and pods. Let's talk about some of the other components of Kubernetes, which is ConfigMaps. A config map is an API object used to store non-confidential data in key-value pairs. Pods can consume config maps as environment variables, command line arguments, or as a configuration files in a volume, which we are going to talk about volume in the next page. A config map allows you to decouple an environment-specific configuration from your container images so that your applications are easily portable. Caution: config maps does not provide a secrecy or encryption. If the data you want to store are confidential, use a secret rather than config map. We are going to talk about secret in the next page. So use additional third-party tools to keep your data private. Now let's talk about the secret, which is an object that contains small amount of sensitive data, such as password, a token, or key. So such information might otherwise be put a pod specification or in a container image. Using a secret means that you do not need to include confidential data in your application code. Kubernetes secrets are by default stored unencrypted in the API servers underlying data store. So there are several options to create a secret. First is using a kubectl, and the second is using a configuration file, and the last one is using the customize tool. So let's now talk about the volumes in Kubernetes. Data stored in Docker container is ephemeral. So it only exists until the container is alive. Ephemeral means not permanent. So when Kubernetes restart a failed or crashed container, you will lose any data stored in a container file system. So in Kubernetes, a volume is essentially a directory accessible to all containers running in a pod, and the data in volumes is preserved across a container restarts. To use a volume, a pod specifies what volume to provide for the pod and where to mount those into containers. Kubernetes supports different kinds of volumes such as empty dir, host pass, NFS, and some other volume types. So these were the most essential Kubernetes components. In the next part 2, we are going to talk about the other components of Kubernetes, such as deployment, stateful set, replica set, and other features. And thank you very much, and see you in the next part.